So in this video, we are going to be looking at the pathophysiology of cystic fibrosis. Right now, what we're looking at is a cell that is lined up by the airway, and this is basically the mucus that is covering the airway wall nicely. So in this normal, healthy individual with a functional CFTR gene, that is cystic fibrosis transmembrane regulator gene, its mRNA is going to get translated nicely with proper protein folding as well as packaging and transported and into the plasma membrane. So with this functional CFTR protein that we have left, it's going to take out these chloride ions out of the cell. What this functional CFTR protein also does when it is functional, it also regulates this sodium channel, so that's called the epithelium sodium channel protein. It basically inhibits the sodium from coming into the cell. And of course, water will follow the solutes into the mucus, and now the mucus covering the wall is nice and moist. Whereas, moving on to our individual with a cystic fibrosis condition with defective cystic fibrosis transmembrane regulator gene, now the protein folding is going to be improperly done, and we are going to end up with a defective CFTR protein that cannot take the chloride ions out of the cell, so that's going to stay within the cell, and it loses its function to regulate the sodium entrance as well. So the sodium entrance is going to be uninhibited going into the cell, and water will follow. And because we have all these water being sucked out of the mucus lining into the cell, we are going to end up with a very thick mucus buildup that's going to likely to trap all these pathogens, and that's going to recruit some immune cells and cause an immune response as well.